Hello, my name is Nathan Gothard. I'm currently an exchange student studying at the University of Newcastle. This is my video presentation for SCID 2100. Today I will be talking to you about one of nature's greatest phenomenon, the aurora. To better understand the aurora, we need to start at its source, the sun. The sun is comprised of approximately 75% hydrogen and 25% helium. At its surface, the sun is about 5,505 degrees Celsius. However, that's nothing compared to the 15 million degrees Celsius at its core. That is hot. The sun produces so much energy that in 1 second it can melt a bridge of ice 149.6 million kilometers long, 3 kilometers wide and 2 kilometers thick instantly. This is just the type of energy we need to produce the spectacular display of lights we call the aurora. What many people don't know is that there are actually two names for the aurora. When an aurora occurs in the northern hemisphere, it is called the aurora borealis. When it occurs in the southern hemisphere, it is called the aurora australis. To understand exactly what causes the aurora, we need to take a trip to the surface of the sun. Solar weather, better known as solar wind, is produced in the sun's outer layer called the corona. The dramatic temperature of the corona supercharges the sun's particles and causes them to change their state of matter to plasma. They begin to move so fast that the sun's gravity can no longer hold on to them, and they stream outward in every direction into the universe. At times, the sun can have large outbursts of these supercharged plasma particles. This is what we call a solar flare, or coronal mass ejection, CME for short. Luckily, the Earth has a defense mechanism. This is what is known as the magnetosphere. The magnetosphere represents the outer bound of Earth's magnetic field lines. As the solar wind collides with the magnetosphere, it gets redirected around the Earth. Although the magnetosphere protects us most of the time, it is not impenetrable. Much like a standard magnet, Earth has open magnetic field lines at each of the poles, called the polar cusps. Due to the open magnetic field lines, some of the redirected plasma particles enter the magnetosphere. Now inside the magnetosphere, a colorful aurora can develop. The plasma particles are drawn to Earth's field-aligned electric currents known as Birkeland currents. This region is still too high in the atmosphere, and a catalyst is needed to push the particles closer to the surface. This usually comes in the form of a CME. Once a CME reaches the Birkeland currents, an explosion of electrical energy sends the charged particles streaming towards Earth. The speeding particles collide with gas molecules in the lower regions of Earth's atmosphere, producing different colors of light depending on the type of gas molecule they collide with. The main colors of the aurora are red, green, and purple, which come from collisions with oxygen and nitrogen. This enchanting dance of lights is one of the many wonders of the world. If you are ever lucky enough to see it, it is sure to be an experience of a lifetime. Thank you for watching my video. I hope you found it interesting.